Hi, welcome to Send to Print. Today we're going to model a Twist Fidget Ball in Fusion 360 and print it. Even though this looks pretty complicated, I'll do my best to break down how everything works step by step. One nice thing about this design is that you can directly change the diameter from the parameter table without breaking any of the functions. Without further ado, let's dive right in. First, let's start by entering the only parameter of the Twist Fidget Ball. Go to the Modify menu and click on Change Parameters. Click the plus icon to create a new parameter. Type in diameter. Set it to 80 millimeters for now, and hit OK. Now, right-click on the root component and select New Component. Name it Twist Fidget Ball. Before we start sketching, let's take a quick look at the design logic of this fidget ball. The whole thing is built from several identical segments, arranged around a central axis to form a complete sphere. At the center, there's a small clearance hole. This prevents the inner tips from fusing together during 3D printing and also helps reduce friction between the segments. Each segment has a raised rail on one side and a matching groove on the other. The neighboring segments interlock with each other, linking together like chain links around the sphere. This interlocking structure forms the interlocking slide. It locks the segments together radially, so they can't fly outward while still allowing them to slide vertically against each other. And that sliding motion is what allows the ball to twist into form. To keep the segments from sliding apart completely, there's also a small rectangular stop feature built into the side of the slide, the captive pin slot. The pin travels inside a closed-ended slot on the neighboring segment. It can slide freely up and down, but once it reaches either end, it's blocked by the wall of the slot. This keeps all the segments securely connected while still allowing smooth movement. All right, hopefully the mechanism makes a bit more sense now. Let's get back to the modeling. Go up to Create Sketch and pick the XY plane. Hit C for the circle tool. Start right from the origin, drag it out, and type in diameter. Right-click to repeat the center diameter circle, and let's set this one to 10 millimeters. Press L for the line tool and draw a line from the origin out to the circle edge. Let's use the Mirror tool under the Create menu. Select that line we just drew. For the mirror line, select the Y-axis. Press D for dimension. Set the angle between these two lines to 30 degrees. Since we're making 12 slices, each segment is 30 degrees. Next up, let's draw the sliding protrusion. Keep using the Center Circle tool. Draw a 4 millimeter circle here. Hit D and set the distance between these two centers to 15 millimeters. Now hit L and draw a line from the circle center to the slice edge. Make sure it's constrained to be perpendicular. Press D again. Let's define the height of this line to 4.5 millimeters. Now, grab the Offset tool and select that line. Set it to symmetric so it offsets both sides equally. Offset 1 millimeter on both sides. Let's drag this point out to intersect with the circumference, and do the same for the other point. If it doesn't snap automatically, use the Coincident Constraint tool here. Constrain this point to the slice edge as well. And this one too. There we go. Our sliding protrusion profile is done. It'll slide freely inside the matching groove on the adjacent slice. Think of this as a modified dovetail joint. The wider head prevents pull-out locking radial movement while allowing vertical sliding. Let's select this center line and press X to turn it into a construction line. Okay, the interlocking sliding mechanism is ready. Now let's draw the other part, the captive pin slot. Hit L for the line tool and draw a line starting from the origin. Constrain this line so it passes through the small circle center. Hit D to dimension the distance from the circle center to this point at 4.5 millimeters. Use L to draw a small protrusion profile on the edge of the circle. Use the parallel constraint to lock these three lines. And make sure these edges are perpendicular. Finally, use the midpoint constraint to align this line with that point. Perfect. We've got a neat little protrusion. Press D to set this line to 3.5 millimeters, and this line to 2.5. Select the middle line again and press X to toggle it to a construction line. So we finished the main interlocking slide and the captive pin slot. The adjacent slice will have the same features. But we don't need to draw them all over again manually. Let's head up to Create, then Pattern, and grab the Circular Pattern tool. Select the profiles of both mechanisms. For the center point, select the origin. Set the distribution to partial. Under Quantity, enter 2. And set the angle to minus 30 degrees. You can see in the preview that the sliding mechanism has been perfectly mirrored over, and hit OK. Now let's select the y-axis projection and hit X to convert it into a construction line. Our slice unit should consist of this main section and these specific profiles. See? The fidget ball is made of 12 identical slices. Each slice has a protrusion and a groove. They interlock like a chain and can slide vertically. Before finishing, check for that small lock icon. It means it's fully constrained. If your lines are still blue, they're under-constrained. We want this logic to be rock solid, so it won't break when you adjust parameters later. Okay, let's finish the sketch and rename it to Slice Unit. Now, we need to draw a vertical line to serve as our sweep path. Click Create Sketch. Select the XZ plane. Press L for line. Draw a line straight up from the origin point. Press D for dimension. Set the height of this line to diameter. Okay, finish sketch. Rename it to Sweep Path. Now we'll build the first slice unit. Find the Sweep tool under the Create menu. Select the main slice profile in that interlocking slide. For now, we're only going to use the interlocking slide. We'll deal with the captive pin slot separately. Select the vertical line as path. Now we have a vertical extrusion. Let's give it a twist angle of 90 degrees. And there's the base shape of our first slice. And it gets that nice spiral form. Before moving on, let's tidy things up. Right-click the new body and rename it to Slice Unit. Okay, let's move on to the captive pin slot. Right-click and repeat sweep. Hide the first body for a clearer view, and make sure the slice unit sketch is visible. Select these two profiles. Use that same vertical line as the path. And keep the twist angle at 90 degrees. Okay. Let's bring the slice unit back into view. For this pin, we only need a small segment in the middle to slide within the limit groove. Press Q for Offset tool. Select the top and bottom faces. For the offset distance, I want this little pin to have a height of 5 millimeters. So we'll enter the formula, minus diameter divided by 2 plus 2.5. You can select the edge to verify. The arc length might be different, but the vertical height should now be exactly 5 millimeters. Now, let's add some clearance to this sliding mechanism. Right-click and repeat Offset Face. Select these 3 faces of the protrusion and enter minus 0.5 millimeters for a loose fit. To print this without supports, we'll add a 45-degree chamfer here. Go to the Modify menu and select Chamfer. Pick this edge. Set the distance to 2.5. Actually, let's go with 2.6 millimeter. Perfect. Now it's 45 degrees and print ready. Let's hide the path for now. Okay, there is our finished little pin. To merge it with the main slice unit, grab the Combine tool from the Modify menu, set the slice unit as the target body, and the little pin as the tool body. Set the operation to join. We don't need to keep tools here, as we're done with that separate pin. Hit OK. To make sure these slices glide smoothly against each other, we need to add some clearance to the mating surfaces. Press Q for Offset Face. Select these 5 faces on this side, and another 5 faces on the other side. Let's offset them by 0.25 millimeters. Since both sides are offset, we get a total gap of 0.5 millimeters, which is quite generous, ensuring a smooth slide. Now, if we were to pattern this slice 12 times around the axis, we'd end up with a cylindrical fidget. But we want a sphere, right? So we need to create a spherical mold. We'll use this mold to trim our slice into the final shape. Go to Create and select Create Sketch. Pick the XZ plane. Hit C and draw a circle using our diameter parameter. Hit L for the line tool. Draw a line from the origin to the edge. Apply a vertical constraint to this line. Then use the coincident constraint to lock the line to the origin and make sure the endpoints snap to the circumference. To avoid overhang issues at the bottom of the sphere, we're going to start the print from a 45-degree angle. Press L to use the line tool. Draw a horizontal line across the bottom of the circle. Then draw a reference line. Use D to set the angle between these lines to 45 degrees. With this 45-degree angle set, the actual print overhang will also be 45 degrees. Now, select this line and hit X to make it a construction line. Now, everything looks fully defined. Okay, let's finish the sketch and rename it to Fidget Profile. Let's use the Revolve tool under Create. Select that flat-bottomed semicircle profile. Pick the vertical line as the axis. Keep it at 360 degrees. That's exactly what we need. Okay, we've got a new body now. Let's rename it to Ball Cutter. Now that our spherical mold is ready, let's trim the slice unit. Open the Combine tool under Modify. Set the slice unit as the target body and the sphere as the tool body. Set the operation to intersect. Make sure to check Keep Tools because we'll need this mold again in a minute. Hit OK. Hide the ball cutter. Now you can see the slice unit has taken on that spherical curve. Don't forget, we still need to cut the captive pin slot so the pin can slide properly inside it. The reason we kept this groove as a separate body is because we still need to modify it before the final cut. Hide the slice unit and bring back the ball cutter. Right-click and repeat Combine. Set this groove body as the target body and the spherical mold as the tool body. Again, set the operation to intersect. You can uncheck Keep Tools this time as we're finished with the mold. Okay. Now, let's refine this groove body a little further. We're going to use this to cut a slot into the slice unit, but to make sure the pin stays locked and doesn't pop out of the top or bottom, we need to leave a thin wall at both ends. That way, the pin hits the wall instead of sliding out. If that sounds a bit confusing, don't worry, it'll make perfect sense in a second. Hide the slice unit again, hit Q for offset face, select the top and bottom faces of the groove body, offset them inward by 2 millimeters. Now, let's bring the slice unit back. Use the Combine tool one more time. Target body is the slice unit, tool body is the groove body. Set the operation to cut. You can uncheck Keep Tools this time as we're finished with the groove body. Hit OK. It looks like nothing happened from the outside. To get a better look at the model, let's go to the Inspect menu and select Section Analysis. Pick the XY plane and drag it up. See that? Even though the surface looks completely sealed, there's now a hidden groove running inside. This allows the pin to slide inside while preventing it from sliding out through either end. Now that our base slice is finished, all we need to do is pattern it 12 times around the center axis to complete the entire fidget ball. Go to Create Pattern, then Circular Pattern. Set the object type to bodies. Select our slice unit. Pick the Z-axis as the rotation axis. Set the distribution to full. Since each slice is 30 degrees, we need a quantity of 12. Hit OK. Just like that, the Twist Fidget Ball modeling is finished. You can see all 12 separate bodies here in the browser. Now that our design is finished, it's time to get it out of Fusion and send it to the printer. Just right-click on your component or the root component in the browser and choose Save as Mesh. For the preparation type, select Print Utility. This is a really useful feature because it creates a direct bridge between your CAD model and your slicer. Choose your slicer from the list, set the format to STL, and make sure your units are set to millimeters. When you click OK, Fusion will automatically launch your slicer and import the model, saving you from exporting and re-importing the file manually. You may also notice that we haven't merged all the separate bodies, but don't worry, this won't affect the print at all. Sending these independent bodies to your printer works perfectly fine, as long as you don't manually split them in the slicer. This model and the Fusion 360F 3D source file are available on MakerWorld. You are welcome to download and check the source file. Through this file, you can clearly see every step of the modeling and the parameters I've used. You can also go back to the fidget profile sketch and change the overall shape. For example, you could turn it into an egg shape. And through the parameters table under the Modify panel, you can easily modify these parameters and customize the dimensions. Okay, send to print. All right, let's check out our Twist Fidget Ball. You can take it straight off the build plate and start playing with it right away. No assembly required. And technically, you can't take it apart either, unless you really force it. Right here is the sliding mechanism. The slices can move freely up and down, but they're mechanically locked, so they can't slip out through the top or bottom. It feels really smooth since we added pretty generous clearances between the sliding surfaces. Okay, that's all for today. If you found this tutorial helpful, please hit the like button and subscribe for more 3D printing designs. Let me know in the comments what should I model next. Thanks for watching, and I'll see you in the next one.